So there's one more problem on this worksheet, problem number 5, HCN. So we'll start doing this problem just like we've done all the rest of them. We'll identify the number of valence electrons. So I've got carbon, I've got hydrogen, and I've got nitrogen. I see that I have one of each, so 1 carbon times 4 valence electrons, 1 hydrogen times 1 valence electron, and 1 nitrogen times 5 valence electrons. And when you add all that up, 4 and 1 is 5, plus another 5 is 10 valence electrons. So I'm going to draw the structure by starting with my central atom, which is carbon, put a hydrogen on one side of that and a nitrogen on the other side of that, and then I'm going to link them all together with a single bond and go from there. So I've now used 10 minus 4, which is 6 valence electrons. And so I'm going to start placing electrons. So I'm going to put 2, 4, 6. So I've used all of my electrons, and at this point, nitrogen only is one of the only atoms that has all 8. So it has 2 electrons in a bond and 6 electrons in dots. Hydrogen is also, and it has the correct amount of valence electrons, which is 2 in the bond. Carbon, on the other hand, only has 4 total valence electrons, 2 electrons from each bond. So this doesn't work out the way that I've drawn it, so that means I'm going to have to create a multiple bond. So the first thing I'm going to do is I'm going to go ahead and grab one of these pairs and put it here. And when I do that, the redrawn structure will look something like this. So I'll have something like this. And at this point, my nitrogen still has 8 valence electrons. This time, 4 of them are in bonds and 4 of them are in dots. Hydrogen is still good, but carbon only has 6. So that tells me I'm going to need to go ahead and grab another 2 electrons. So I'm going to grab probably these 2 and put it here. So when I re-clean up this structure, I'm going to have something that looks like this. Like this. Now, nitrogen has 8 electrons, 2 in dots and 6 in bonds. Carbon has 8 electrons, 8 in bonds, and hydrogen has 2 electrons, 2 in bonds. So all of the atoms have 8 valence electrons or 2, and so that is the most correct structure for HCN. Now we need to go and identify the types of bonds present. So we have hydrogen and carbon, and we have carbon and nitrogen. So I'm going to set this up where I'm going to identify my electronegativity differences. So hydrogen has an electronegativity value of 2.1. Carbon has an electronegativity value of 2.5. Nitrogen has an electronegativity value of 3.1 or 3.0. So now I'm going to do some subtracting. And I'm going to see that the first one is 0.4, which is a non-polar bond. And the next one is going to be 0.5, which is a polar bond. Now, in a non-polar bond, there's no dipole arrows to draw. But in a polar bond, there are dipole arrows to draw, and we draw them in the direction of the more electronegative element. So I'm going to draw that down here like that. We also have to add partial charges. So we are going to have a delta negative on the more negative side, or on the larger electronegativity, and a delta positive on the smaller electronegativity. So that would be delta negative and delta positive, like so. We're going to go ahead and identify the VSEPR geometry here. I do have a central atom, so that's going to be my A. I have an X2, because there's hydrogen and nitrogen attached to it, and an E0, which means there's nothing. No unshared pairs of electrons on the central atom. So if I go way back up to the top, the only 2 options that have 2 atoms bonded to the central atom only are linear and bent. Bent has unshared pair of electrons on the central atom. Linear does not. So that means that this structure needs to be linear. Now the question is this a polar or a nonpolar molecule? And the answer here is going to be a polar molecule. Now, it's a polar molecule because there is a dipole arrow, and the dipole arrow is being pulled away from carbon. And there's nothing to counteract that. There's no other dipole arrow pulling in the direction of hydrogen. So what we can simply say is that it's a polar molecule because the dipole arrows do not cancel out. And so there you have it. That's the solution for problem number 5 of worksheet 8 from unit 7. If you have any questions on this problem or any of the other problems on this worksheet, please let me know.